Hello, girls. I hope you're having a great day and staying safe at home. To continue with the water chapter, okay, we were discussing solutions in the last upload. So, today we are going to learn about hydrated and anhydrous substances. Now, hydrated means substances which contain water molecules attached to them. Okay, so there are salts like sodium carbonate decahydrate. Deca means 10, so to sodium carbonate 10 molecules of water are added to it. And similarly, copper sulfate pentahydrate. Penta means 5, so it is copper sulfate with 5 molecules of water loosely attached to it. So these type of substances are known as hydrated substances. And substances which do not contain any water along with the salts, they are anhydrous. Okay, for example, sodium chloride NaCl, no water attached to it. Potassium nitrate KNO3 does not have any water attached to it. Now, hydrated substances, the crystals. So hydrated substance always form crystals, they have crystalline structure. So the crystals of some salts contain water of crystallization. Okay, so the water which is contained in hydrated substances is known as water of crystallization. Now this water gives the crystals their shape. The shape is because of the water of crystallization present in them, and in some cases they also give a characteristic color to the salt, like in the case of copper sulfate crystals which are blue in color, but anhydrous copper sulfate which does not contain the 5 molecules of water attached to it, they are white in color. So these salts are known as hydrated salts. So moving on to the water of crystallization, there are some solids while they are crystallizing out from their solutions. Remember, when we heat a saturated solution, more solute can be added to it, and when we cool it, the extra solute will come out as crystals. So when they're coming out from as crystals from the solution, a little amount of water will get combined with it, which is known as water of crystallization or water of. So, to define the water of crystallization, it is defined as the fixed amount of water that is associated with some compounds, which is an integral part of their crystalline structure. Integral means the main part. If it is not there, then the salt will not have a crystalline structure. So this is the definition of your water of crystallization. Now, this water of crystallization is in loose chemical combination, okay, and you can easily drive it off when you just heat the crystals above 100°C. Now the vapors produced are condensed and the liquid which is formed is tested. So when you test the liquid formed, it will give the test of water. Okay, in this process, the crystals lose their water and become anhydrous. Anhydrous means it is dry, it does not have water of crystallization. So when we heat it, all the water combined in the crystalline material is removed. It just goes off as water vapor. Now there is an experiment to show that hydrated copper sulfate crystals, also known as blue vitriol, children, this is very important, please keep in mind, it contains water of crystallization. So what do? Very simple. Take a look at this diagram. We take some copper sulfate crystals here in a test tube, in a dry test tube, and we clamp it in a tilted position. Why tilted? So that water which is formed will form here and then it will fall off from here, okay, so that it doesn't go back. So what do we do after tilting it? We heat the test tube. What do you see? You'll see drops of colorless liquid condense on the cooler parts of the test tube. The cooler parts, of course, naturally is the top of the test tube, which is not receiving the heat. Okay, so you will see that anhydrous powder is left behind, and amorphous means which is not crystalline in shape, and it is a powder, a white colored powder will be formed. Okay, and when blue crystals of hydrated copper sulfate is heated in a test tube, they turn into a white powder. What is the color of hydrated copper sulfate? It is blue in color. So the type of question you'll get is, blue colored crystals are heated, it turns into white powder. So accordingly, questions will be asked. Okay, now, and when you sprinkle a few drops of water on the white powder, you will see that it will turn into a blue solid again. So this is your equation. Okay, copper sulfate 0.5 H2O, when you heat it, copper sulfate plus 5 H2O, and it is a reversible reaction. Why? Because when you add a few drops of water to anhydrous copper sulfate, again it will turn into hydrated blue colored salt. Children, for your assignment, you are supposed to write down this table and learn it by heart as well. Now next, we are going to learn about anhydrous substances. Now, as you already know, when is a substance anhydrous? If it does not have any water content in it. Okay, for example, salts lacking their water of crystallization. So when we talk about anhydrous, we are talking about crystalline substances when the water of crystallization is removed. So we have hydrated copper sulfate and we have anhydrous copper sulfate after the water of crystallization is removed. Okay, and when we talk about anhydrous, it is also refers to the gaseous form of some concentrated solution such as ammonia, to distinguish it from its aqueous solution form. When we say anhydrous ammonia, that means it is gas, ammonia gas. Okay, and when we say aqueous ammonia, that means it is in solution form. Now, anhydrous solvents are used to perform certain chemical reactions which cannot take place in the presence of water. So what must we use? We must use anhydrous. Anhydrous means in the gaseous state. Now, example of anhydrous substances which do not contain water of crystallization is table salt, anhydrous sodium chloride. Gaseous hydrogen chloride is anhydrous because it does not contain water. If hydrogen chloride is put in water, then it will turn into hydrochloric acid. Okay. Now, anhydrous salts can be obtained from hydrated salts by removing, you already know, what do we remove? We remove water of crystallization. So the first one we already did by direct heating, or we heat it in dry and hot air, or we heat it under a vacuum, or by using dehydrating and desiccating agents. Dehydrating and desiccating agents like concentrated sulfuric acid removes the water which is loosely attached to hydrated salts. Okay, now remember children, not all salts are not all crystalline salts which are in the form of crystals, okay, are due to the presence of water of crystallization. So the crystalline shape of a substance is not necessarily the result of the presence of water of crystallization. Now there are many crystalline solids in the laboratory that crystallize out from water without any water of crystallization. They come out as crystals, but it does not have any water of crystallization. Now these examples are very important. This is also, you're going to write this also for your assignment. Okay, now examples of crystalline substances which do not have water of crystallization: common salt, niter, potassium nitrate, sugar, potassium permanganate, and ammonium chloride. Okay, now next we move on to an experiment to study the action of heat on crystals of sodium chloride and potassium nitrate which do not have water of crystallization. So what do? We heat a few crystals of pure sodium chloride in one test tube, and in another a few crystals of potassium nitrate. So what do you see as you heat it? You'll see that the crystals of sodium chloride produces a crackling sound. Okay, and this crackling sound is known as decrepitation. Okay, and why does this crackling sound, why do you hear it? It is due to the breaking down of bigger crystals into smaller ones. Because of the heat, big crystals of sodium chloride will break down into smaller ones. But when you see the crystals of potassium nitrate, you'll see that it will first melt into a colorless liquid, and then when you keep on heating it strongly, they produce oxygen The test for oxygen, children, it rekindles a glowing splinter. Okay, I think I already mentioned what a glowing splinter is. Okay, now potassium nitrite, which is a light yellow solid residue, is left behind. Okay, so potassium nitrite is light yellow in color. The colors I told you are very, very important. So as you can see here, both the substances do not have water of crystallization. Okay, now moving on to the different properties. The first property is known as efflorescence. Now, when we talk about efflorescence, we are talking about a phenomenon where a compound loses its water of crystallization when exposed to dry air. It is known as efflorescence. And what happens when water of crystallization just evaporates into dry air? It loses its crystalline shape and it crumbles into a fine powder. The crystal loses its crystalline shape, and substances showing efflorescence are known as efflorescent substances. Now, when does efflorescence take place? When the vapor pressure of the hydrated crystal is more than the atmospheric vapor pressure. So, when it is humid, where there is water vapor in the atmosphere, then they will not lose the water into the atmosphere. Examples of efflorescent substances, very important, children. So this is your next assignment for this upload only. You'll write down the example of efflorescent substances as well. The first one is washing soda, which is hydrated sodium carbonate. So when you leave hydrated sodium carbonate outside, you will see that it will become a monohydrate. Monohydrate, out of 10 molecules of water of crystallization it contains, 9 will just evaporate, leaving behind only 1 molecule of water. The next example of efflorescent substance is Glauber's salt. Children, these common names are also very important, which is sodium sulfate decahydrate. Again, 10 molecules of water is loosely attached to it. So it loses its 10 molecules of water of crystallization and turns into a powdery anhydrous sodium sulfate when exposed to air. Next is Epsom salt, which is magnesium sulfate heptahydrate. So magnesium sulfate contains 7 molecules of water loosely attached to it. So when exposed to air, again it loses its 6 molecules of water and 1 will remain back. It becomes a monohydrate. Mono means containing 1 molecule of water of crystallization. And please remember, children, higher the temperature of the air, higher is the efflorescence. That means more water can be evaporated off. Next is deliquescence. Now, there are certain water-soluble substances, when they are exposed to the atmosphere at ordinary temperature, they absorb moisture from the air. Remember, children, they do not give out like efflorescent substances, but they absorb moisture from the atmospheric air. They become moist and lose their crystalline form, and it will dissolve in the absorbed water, forming a saturated solution. So this type of substance is known as deliquescent substance, and the phenomenon is known as deliquency. So deliquescence occurs when vapor pressure inside the crystal is very low when you compare it with vapor pressure of the atmospheric air. So deliquescence becomes less during dry conditions. Now, examples of deliquescent substances. So please add this example in your assignment as well. Okay, deliquescent substances, examples: caustic soda, caustic potash. Please remember, children, the common name of sodium hydroxide, caustic soda, caustic potash, potassium hydroxide, magnesium chloride, zinc chloride, calcium chloride and ferric chloride are all deliquescent substances. Now, if you have noticed, children, the table salt that we have, it turns moist. If you leave it outside, especially during the rainy season, it will turn watery, if you have noticed. Okay, but remember, pure sodium chloride is not deliquescent, but the commercial version which we buy from the market has impurities like magnesium chloride and calcium chloride, which are deliquescent substances. And you know, sodium chloride dissolves in water, and due to the presence of magnesium chloride and calcium chloride, which are deliquescent, they will absorb the water vapor from the atmosphere, and sodium chloride will also dissolve in it. So we can remove this impurity. How? By passing a current of dry hydrogen chloride gas through a saturated solution of the affected salt. Now pure sodium chloride is produced as a precipitate which can be recovered by filtering and washing, first with a little water and then afterwards at the end you wash it with alcohol. Now next property is hygroscopy. Okay, certain substances absorb moisture just like deliquescent substances, okay, from the atmosphere, but they do not dissolve in the water. So when they are exposed but not enough to form solutions, so such substances are known as hygroscopic substances. Now if we look at hygroscopic and deliquescent substances, only difference you can see is both will absorb the water vapor, but deliquescent substances will dissolve in the water. Hygroscopic substances will not dissolve in the water that it had absorbed. So this phenomenon is known as hygroscopy. Now this is also, you're going to add the example of hygroscopic substances in the assignment: concentrated sulfuric acid, phosphorus pentoxide, quicklime, calcium oxide, and silica gel. You have seen no small packets inside shoes or bags. What is inside there? Silica gel to absorb any moisture. So hygroscopic substances, they have a tendency to take up the moisture from the air, and they can be in solid state as well as in liquid state. So next, moving on to drying and dehydrating agents. Now drying agents are substances that can readily absorb moisture from other substances, but they do not react with it chemically. They can only absorb the water from other substances. For example, anhydrous calcium chloride, anhydrous zinc chloride, phosphorus pentaoxide, magnesium sulfate, dry sodium sulfate are used to absorb water vapor from the air, and these substances will not react with water vapor from the air. So these substances are known as desiccants or desiccating agents which absorb moisture from the air. So almost all the hygroscopic substances we just talked about are desiccating agents, like concentrated sulfuric acid, phosphorus pentaoxide, silica gel, and quicklime. Okay. Next, moving on to dehydrating agents. Okay, dehydrating means to remove water totally. So dehydrating agents are substances that can remove even the chemically combined water molecule from compounds. Example of dehydrating agents are concentrated sulfuric acid. Okay, it can remove the chemically combined molecules from blue vitriol. Now this 5 molecules of water is chemically combined with copper sulfate, so this water also it can easily remove. So when we pass concentrated sulfuric acid, when we bring it near copper sulfate, it will remove the 5 molecules of water which is attached to it. Now dehydrating agents can remove hydrogen and oxygen in the ratio 2:1 in the form of water. Okay, so you can see from here how concentrated sulfuric acid has removed 11 molecules of water from sugar. Now some more dehydrating substances, examples: aluminum oxide, also known as alumina, and phosphorus pentaoxide. Okay, now gases are dried by passing the gases. Sometimes gases have water vapor mixed with it, so these gases must be dried. Water vapor should not be mixed with these gases, so we can dry these gases by passing it through concentrated sulfuric acid, because concentrated sulfuric acid has a strong affinity for water, means it can easily remove the water, so it extracts the water from many substances. Now concentrated sulfuric acid, it is used to dry gases which are acidic in nature, like hydrogen chloride gas. That means acid and acid, they will not react with each other. Okay, next is we also dry them by passing them through a drying tower or a U-tube containing quicklime or anhydrous sodium sulfate. So this is sulfuric acid. Okay, now this one passing through a drying tower. This is your drying tower. So gas pass through here and then it will go up here. Okay, so what is this? This is the drying agent. So here it may be quicklime, calcium oxide, or anhydrous sodium sulfate, or from this U-tube also gases pass down here, pass through the drying agent, and from here what do you get? Dry gas comes out. So from here dry gas will come out. Similarly here also, through this bulb, what is here? Drying agent is here. What comes out from here? Dry gas will come out. So this is a drying bulb containing anhydrous calcium chloride. Remember, quicklime is basic in nature, so it is suitable for drying ammonia, which is a basic gas. Base and base will not react. Okay. Now liquids are dried. Now some liquids need to be dried. Water needs to be taken out. So they are dried by keeping them overnight, that is the whole night over anhydrous sodium sulfate or magnesium sulfate or calcium chloride at room temperature. Okay, then the solid is removed by whatever solid comes out, it is removed by filtration. Now solids are dried by spreading them on a watch glass or a dish and keeping it in a desiccator for some days. Now what is a desiccator? Here you can see is a desiccator. You can see it is an airtight glass vessel. It is, this entire thing is made up of glass. Okay, and there is anhydrous calcium chloride here at the base, at the bottom. So whatever solid needs to be dried, it is placed inside here, and then we keep them for some days and the solid will get dried. Okay, so you know I've already given you the assignments in the middle of this upload. You will draw the diagrams that is given here. Okay, the drying bottle containing concentrated sulfur figure 3.12 as well. All the 4 diagrams, and of course I nearly forgot, you draw the diagram of a desiccator as well. Okay, now we already talked about drying agent and dehydrating agent as well. Please go through this difference that is given in this table. So children, with this we come to the end of the water chapter. Okay, after that we are going to talk about soft and hard water, the one section of the water chapter. Okay, after that we'll move on to the third part, that is soft and hard water. So you know what your assignment is. So children, in the next upload we will meet again. Till then children, stay safe. God bless you.